Today we are going to discuss the topic about equivalent circuit of induction motor. The three-phase induction motor is generally treated as a rotating transformer. The transformer has two windings. One is primary winding and another one is secondary winding. Similar to that, induction motor primary winding of stator and secondary winding is a rotor. This is the equivalent circuit of primary and secondary winding of the induction motor. First of all, V1 is a supply voltage and E1 is a induced EMF in stator and E2 is a induced EMF in rotor. R1 is a stator resistance and R2 is a rotor resistance. X1 is a stator reactance and X2 is a rotor reactance. E2R is a rotor induced EMF. When the induction motor operates under no load condition, it draws some current from supply. It's produced flux IW and I mu, so that total I naught current is equal to IW plus I mu. Then I mu is a magnetizing component and IW is the working component. Then I2R is a rotor current under running condition, so that I2R is equal to E2R divided by Z2R. Then is minimized to the SE2 divided by root of R2 square plus Sx2 the whole square. The equivalent circuit of rotor circuit is now the variable resistance can be written as R2 divided by S, R2 plus R2 divided by S minus R2. So that R2 divided by S and R2 bracket of 1 minus S divided by S. The approximate equivalent circuit drawn simplify calculation deducting one node. The shunt branch is shifted towards primary side. This can be done voltage drop between the stator resistance inductance. There is not much difference between supply voltage and induced voltage. The magnetic circuit induction motor has an air gap flux, so exciting current is larger compared to transformer, so exact equivalent circuit should be used. The rotor stator inductance is larger in induction motor. In induction motor, distribute winding is given below. Power election of equivalent circuits. We know that power formula is 3V1 I1 cos theta. V1 is a applied voltage and I1 is a current and cos pi is a power factor. In rotor is power input is equal to minus stator and iron loss. Rotor copper loss is equal to slip into power input of the rotor. Developed power is equal to 1 minus S into rotor input power. Then approximate equivalent circuit. The approximate equivalent circuit is this difference between the single phase and three phase equivalent circuits. The single phase induction motor circuit given double field revolving theory states stationary pulse magnetic field of the motor. This is the statements of equivalent circuits. And equivalent circuit of three phase inductor motor. This is the final one circuits of three phase induction motor. Then the approximate equivalent circuit of induction motor, write following assumption. Exciting branch is neglected IO and transformation K is unity. From the diagram, output is Pm is equal to 3I1 square Rn. I1 is equal to V1 divided by root of R01 plus RL the whole square plus X01 the whole square. Next, maximum power is equal to 3V1 square RL divided by R01 plus RL the whole square plus X0 the whole square. This is the equation of maximum power. and R1 R2 dash is equal to R01 and X1 and X2 dash is equal to X01. Thank you.